Alright, so there's three properties of logarithms that you need to know to either be able to push together a logarithmic expression or take apart a logarithmic expression. So here's the first one. The first one says that if we have log in the base of a and we have x times y, because they're related to exponents and because of the law of exponents, and you can look that up on Google if you want more information, we can rewrite this as two separate things added together. Log base a of x plus the log base a of y. The next thing, another one is very similar. If we have log base a of b divided by c, we can rewrite that as a subtraction problem. Log base a of b minus log same base a of c. So multiplication goes to addition. Log that has division in it separates into two logs with subtraction. The last one's kind of cool too. The last property of logarithms, this one is if we have log base a, and we'll say that it's going to be b of something with an exponent, we can rewrite that and we can bring the exponent out front. So the 3 comes out in front of the log, and we still have base a, and then it just simplifies down to b. And again, all those are related to the properties of exponential functions or equations, which you can look up. So let's say that we need to expand one. So let's say that they're asking us to expand the log, let's see, of z to the fifth over x. So first thing to notice is that it's a single log put together. We have division here. Based on our division, we're going to start, because the main thing is division, z5 divided by x. We're going to use this property, the second property listed. So we're going to rewrite it as log z to the fifth minus log of x. There's one more way that we have to expand it. We don't have any more multiplication or division hanging out, but we do have an exponent. So this one here, the exponent is 5, and using the third property that we have listed above, the exponent's going to go out front, so it's 5 times the log of z minus the log of x. And that's all you can do. There's no equal sign, so you can't solve it. We don't have enough numbers to punch it into a calculator and evaluate. So that would be the basic way that you would expand one. Let's try another one. Let's see. For this problem here, we're going to have that the log, I lost my place. Let's take the log of, that's very similar. We'll say y to the cubed times x. So if we're expanding this again inside the parentheses, we have something with an exponent, which we'll deal with in a minute, but we do have multiplication between two items. So we're going to separate that multiplication out. So we're going to have the log of y to the third. Because it is multiplication, we separate it with addition. Log of x. We just kind of glance at both of them. This one here still has an exponent in it. So we're going to use the property about exponents. The 3 comes out in front of the log. And then we just copy the rest of the expression the way it was. Alright, let's try one more here. It might seem kind of the same, but that's all right. It might reinforce some of the things that we're writing. So let's say that we have the log of z over y to the fourth. Again, the first thing I notice is the division. Division tells me that I'm going to use subtraction, so I'm going to start with that. Log of z minus, so I'm separating it into two different logs. Then I just look at both of my terms, see if there's any exponents. This one here has an exponent, so I'm going to bring that 4 out in front. Not out in front of both, just in front of that last term, okay? The 4 just zips here. So 4 times the log of y. And again, that is as far as you can go with that, that expression. That is called an expanded expression. All right, I hope that helps. Thank you.